at the Nikon booth here at Quality Expo here in Chicago. I've got here with me Banu Singh, who is a business development manager for Nikon, is that right?
For the Vision products.
For the Vision products,
That's correct.
And what are we going to look at today?
What we're looking at today is our non-contact video metrology system. This is our high accuracy, high throughput system. It's a non-contact vision based, and this is our third generation. We're introducing our third generation tool at this show. It's our Nexiv system, so it's third generation Nexiv, which means Nikon's excellence in vision metrology.
I always wonder what Nexiv meant. Yeah, there we go. Now, what makes this different? What makes this difference from your other machines?
From the previous machine, this is a higher accuracy, and a lot of the higher accuracy comes from the linear encoders, or basically the measuring linear encoders.
Okay.
And that technology is coming over from our precision department. So we have a precision department that makes the stepper scanners for the semiconductor business.
Okay.
So we're incorporating that high precision technology into the system. So higher end components, stronger laser, more capable laser. The software's been revamped, so it's been revitalized and updated. A lot of 3D graphics and so forth. So
and this looks like a larger than the other Nexiv machines.
It's a larger scale. I'm glad you mentioned that. It's actually 450 by 400, so that's why it's the VMZ R4540, and it's designed for larger parts, or also if people want to put on multiple parts, so they can put on a whole load of parts, walkaways, load and go, and also it's got a 200 millimeter Z-stroke, so taller parts.
And what are some of the features of this?
Some of the key features, this is actually a multi-sensor system, so one of the basic sensors, the most fundamental one is the vision sensor.
Okay.
So the vision sensor, the advantage over that with some of the CMMs, you'll see here is that it can collect thousands, hundreds of thousands, and even millions of points very quickly without touching the part, versus tactile machines which have to collect one at a time.
Yeah.
The other sensor is a TTL laser, which simply means it's a through-the-lens laser, and it also gathers surface data. So you can use the TTL laser to focus on the part. You can use it to scan the surface of the part, and you can also do it to characterize the surface. So if you wanted to look at surface roughness or the profile, you could scan it with the laser.
And would the laser scanner have a higher accuracy than the vision system?
That's a good question. It typically does.
Okay.
So the laser is typically quicker, more repeatable, and more accurate.
Okay.
The other nice thing about the laser is the laser doesn't care what magnification you're at. This system has 5 mag positions.
Okay.
So for the vision, the higher mag you go, typically the more accurate, the more repeatable you are, because your pixel resolution increases. But the laser, because it's independent of the zoom optics, it doesn't care what magnification you're at, and it doesn't care what the illumination is.
Tell us about the ring light, because I think this is really interesting what you guys have done with the ring light.
One of our fundamental advantages we feel that we have is the algorithms we put in for edge detection. But the edge detection algorithms are only as good as the edge that you can illuminate.
Sure.
So we have 2 strategic things there. One is the illumination that you mentioned. So for illumination, we have 3 different types of illumination. We have illumination from the bottom, which is the diascopic, episcopic, and then the ring light that you were asking for. The ring light actually has 3 positions. And the advantage of the ring light is it's called oblique lighting, and it comes in and it hits the part at an angle. So anything that has any kind of height, curvature, or surface to it, it enhances it very nicely so that you can measure exactly the edge that you're trying to get to.
Right.
Which is very important, because in a real world, typically customer parts have multiple edges, so you want to be able to pick the right one according to the design of the manufacturer of our customers' parts.
Right.
This ring light, another new feature over some of our older systems, is that it has additional positions. So you can drop it down 1/3 of the way, 2/3, or 3/3, depending on how you want to pick up that edge.
And that's clever, because what that does is that changes the angle that the light is hitting the edge, right? As you raise and lower the ring light, you're going to change the angle at which the light is hitting the.
Yes, sir.
And that's what helps you enhance the edge.
Yes, sir. That's correct.
I've never seen that before. I think that's really cool.
People actually ask, can we adjust how much it drops down?
Yeah.
The answer to that is the LEDs that are inside the ring light are actually angled to optimize for how far it drops down. So when you drop down this far, there's one row of LEDs that are angled in, and when it drops down, it illuminates the other row, which is angled differently.
Oh, okay.
And you're absolutely right. If you have every other lighting off and you drop this down, it's almost like a dark field inspection, things you would find on particle detection, defect detection machines.
Right.
So the machine is capable of not only measurement, but you can also do inspection, you can do defect qualification, quantification, find defect location, cracks, things of that nature on the surface.
Okay. And what market is this intended for?
The markets that we're into, we're very fortunate that way. It's very applicable toward automotive, medical, semiconductors. So we see a broad range of applications.
Okay. And obviously, you've got a somewhat limited field of view. If you're scanning a larger part, everything gets stitched together, I'm assuming?
That's one important thing, is being able to calibrate across the entire work surface.
Okay.
So we have proprietary calibration that allows us to do correlate field of view to field of view measurements. So regardless of whether you're inside the field of view or across the entire 450 by 400 surface area, all the measurements are coordinated. But not only across the stage, also across the sensors, because you want your laser data to be meaningful with your vision data.
Sure.
And then on some of our other systems, we even incorporate a third sensor, which is the touch probe. So one of our key advantages is being able to cross-calibrate so that all three sensors can be used in the same measurement program interchangeably.
Right. Okay. What about software with this?
Software-wise, it's called AutoMeasure.
Okay.
It's been around since the 90s. This is our third generation of it. It's been updated with some 3D graphics, more point clouds. This particular one takes advantage of 64-bit processing.
Okay.
So as I mentioned earlier, on the vision side, you can collect a lot of data very quickly. When the laser is scanning, you can collect up to 1,000 points per second on the surface. So you got to be able to process that data in a meaningful manner. Okay. So the AutoMeasure software not only measures the dimension, it also helps you apply geometric dimensioning and tolerancing. It tells you if your part passes or fails, but it is also able to transfer that data into some other analysis packages, where you can compare to CAD files and so forth. So.
Terrific. Okay, Banu, so this was the third generation Nexiv, right?
We're very proud to present the third generation. It's better accuracy, better hardware, better software. We already have an excellent tool, excellent in the market, but even better, more improving on our return on investment for our customers. With the added capabilities, we're reaching into new markets. For example, the laser, it's able to look at thin transparent materials, and it's able to separate the top surface from the back surface. Very important for a lot of our electronics customers, medical customers. So we're very excited about the new capability. We're excited about the new size and the new accuracy, the linear encoders, and so forth.
Okay, so, terrific. Well, Banu, thank you. Thank you for running us through the Nexiv.
My pleasure. Thank you for your time.
Sure, no problem. Back to you, Mike.